Hello, my name is Michaela Spence, and this is my Computer Science 499 Capstone course code review for my project. And the artifact that I chose will be used for all three requirements in the course. The artifact is from Computer Science 360 and is the assignment called Event Track App, where events are stored and displayed for a user. In this walkthrough, I will examine the existing code, analyze its strengths and weaknesses, and explain my planned enhancements across the three required areas of software design and engineering, algorithms and data structures, and databases. And the goal of these enhancements is to demonstrate my growth in the computer science program by improving the efficiency of my code, the structure, and the overall scalability. So as far as the existing code, the Event Track app is an Android application that allows users to register, log in, and manage events, update, delete. It currently stores user credentials and event data in an SQLite database and provides a user interface for event management. And so as far as there we go. So this here at line 50, that is the login functionality that verifies user credentials. It's stored in SQLite by calling the check user. If it's valid, the user then proceeds to the event display screen. And that's through event display activity. And then in register activity, here at line 41, that's where we're registering users. It adds new users to the database by calling add user from database helper.java. And then in event display activity, here at line 70, that's where we'll load event data. This method retrieves all stored events and displays them in a grid view, which you can see running over here. Events are retrieved via the get all events, and events are retrieved via get all events in the database helper.java. And then line 91 here, that is the get all events, and this class manages the database interactions, including storing and retrieving user credentials and event data. So as far as the topic of software design and engineering, while the app is functional, there are several structural weaknesses that could have improvement. So for the event display here at line 79, it's where we have, I'm sorry, start with line 70. That's where we have load event data. There's tight coupling there. The user interface components directly interact with the database through database helper instead of a dedicated controller class. And then down here at line 79, for the show event dialog, there's no separation of concerns, so business logic for event updates and deletions is embedded in the user interface instead of a separate controller. And then in database helper, line 108, so there are else statements at line 108, and here we go, 129. It's unreachable code and test stubs. So some old routines, unused code that I will look at fixing. And then in database helper as well, line 91. Here we go. For the get all events here. There's inefficient storage use. It loads all events instead of fetching only required data, which could lead to potential performance issues. So solutions for this: to improve maintainability and scalability, I'll refactor the code to follow the model view controller pattern, MVC pattern. So the plan would be to create a new Java file here that would be the event controller.java. And I would, for model database helper.java, currently handles the database interactions. View activities such as main activity.java and event display activity.java will handle the user interface. And controller, so event controller.java, which is yet to be created, will process user actions and communicate between the user interface and database. So what will this improve? It'll be cleaner, modular, and more maintainable code that will allow for easier debugging and testing, and there will be better separation between logic and user interface. So as far as the requirement for algorithms and data structures, the issues we currently have. Currently, event retrieval is inefficient due to the use of an array list, which results in a 0 search time when looking for a specific event. Additionally, there is no search or filtering functionality. So in Database Helper here, this is where we're looking at. So it's slow search and retrieval. Retrieving all events requires iterating over an entire list. There's no search or filtering, so users cannot quickly find events by name or filter by date. And there are loop inefficiencies. Some of the loops could be optimized for better performance. And hard-coded values also should be replaced with named constants. So to improve efficiency for my algorithms and data structures, I will implement a hash map to store events, allowing O to the 1 lookups, and introduce search and filtering features. So this would be in the new file I'm going to create for the event controller.java, where I'll add date filtering, allowing users to filter events within a specific date range, and improve defensive programming, so validate user input to prevent crashes and ensure that search queries are properly sanitized. And finally, for databases, currently the application relies solely on SQLite, which presents limitations in terms of data persistence and accessibility. Additionally, there are areas of improvement for my indexing, error handling, and memory management. So right now there's local storage only, no cloud backup. So data loss is possible if the app is removed or the device is reset. There's no indexing, so queries could be slow due to the absence of any index columns, and poor error handling. It does not gracefully handle database failures. And finally, memory allocation issues. I'll need to ensure that the database connections are properly closed after use. So as far as a solution to these problems, to improve reliability and scalability, I will try to integrate Firebase Firestore while maintaining SQLite as a local cache. I will create a new file called upload event to Firebase within, a new function, upload event to Firebase in event controller.java, the one I've yet to create. And this will leave us with a hybrid database approach. So SQLite for fast local storage, Firebase for cloud backup, which will be integrated through that event controller.java. Automatic syncing, so events added locally will be backed up to Firebase, and enhanced error handling. So I'll implement try-catch blocks to manage database failures gracefully. So in conclusion, my planned enhancements improve the structure, efficiency, and reliability of my current event track app by applying software engineering principles, optimizing algorithms, and integrating cloud storage. This will demonstrate several different skills. So for software engineering and design, the MVC architecture. For data structures and algorithms, optimized searching and filtering. And for database management, hybrid SQLite and Firebase integration. Thank you for watching my code review.